Assalamu alaikum everyone. My name is Aizur Rahman and I study in Iqra Virtual School, Grade 7 Green. Today we are going to explore the interesting world of the Newton's cradle, a device that beautifully demonstrates the principle of physics. The Newton's cradle consists of a series of identical balls suspended in a straight line. Now I will tell you how I made this model. First, I started by selecting wooden pieces to ensure the durability. I carefully joined the pieces to create a sturdy frame that will support the swinging balls. After that, I attached the balls. I carefully aligned them in a straight line and attached them tightly. Now I will tell you about the history of the Newton's cradle. The Newton's cradle is named after Sir Isaac Newton, but he did not invent it. It was actually invented by a French scientist called Edmé Mirotti in the 17th century. The device is a perfect example of the Newton's third law, which is for every action there is an equal and opposite reaction. Now I will demonstrate the Newton's cradle. Now let's see the Newton's cradle in action. Observe how the energy is transferred from one ball to the next, causing the last ball to swing out. Now let's lift two balls and release them. Notice how the two balls on the opposite end swing out, demonstrating the conservation of momentum and energy. Now I will explain you three terms using another model that I have made. First, I will explain what is conservation of momentum. The conservation of momentum means the total momentum of a system remains constant when one ball strikes the next. Its momentum is transferred through the series of balls. Over here you can see the model. When we strike one ball with these balls, on the other end one ball slides away. This shows that the momentum from this ball hits and it travels through, and from the other end, as there is no ball where the momentum can be transferred, so the ball slides away. Next is the conservation of energy. We know the movement energy is called kinetic energy, and in the Newton's cradle, the total kinetic energy of the system is conserved. The energy from the moving ball is transferred to the next ball, and so on until at the last ball where there is nowhere for the energy to be transferred, it swings out, and when it comes back and hit, the cycle continues again. Last but not least, the electric collision. The collision between the ball is nearly elastic, meaning that there is minimum loss of energy due to heat or sound. As we know that while energy transferred, we can there is loss of any energy. But when one ball hits the other, there is very less energy being wasted, and the energy is only being wasted in sound and very less heat. Now I will tell you about no, but first let me demonstrate this pro model by hitting the balls. First, I will hit one ball with these balls. Now notice how that from the other end, one ball will come out. Yes, because the momentum of one ball at the end stops and the one ball slides out. Now when I will hit two balls, the momentum of the two balls is applied. So two balls comes out. And at the end I will do three balls. And notice how the momentum of the three balls has hit the three balls, and the balls that hit stay still, and on the other hand the three balls come out. Now I will tell you some fun facts about the Newton's cradle. Did you know the Newton's cradle is not just a desk toy? It has practical applications in demonstrating physics concepts in a classroom and laboratories. It also used in engineering to study the behavior of colliding bodies in various scientific experiments. Fun fact, the Newton's cradle has appeared in numerous movies and TV shows as a symbol of science intellectualism. In short, the Newton's cradle is a simple yet powerful device that illustrates the fundamental principles of physics. I hope you enjoyed the demonstration and learned something new about the fascinating worlds of physics. Thank you. I hope you like my presentation.